All right, all right, all right. Let's get back to work. Let's do some exciting stuff here. We're looking at when Newton's method fails, and it can fail. One example is if the derivative equals 0 at one of our steps and f doesn't, you end up having, like, you can't do L'Hopital's or anything to go forward from there. The iterative process breaks. We can't divide by 0. So when you're hitting answer on the calculator, it's trying to divide by 0. It's going to say error, okay? It can also approach a different route, as our first example is going to show us. And this is oftentimes from a bad initial guess, but sometimes it just goes wildly astray and never gets you anywhere. And sometimes it may not approach a route at all. Like it just keeps bouncing you back and forth across long distances, or it might oscillate between two numbers. If we do f of x equals x cubed minus 2x plus 2, f prime of x is 3x squared minus 2. And if we do f of 1, we get 1. And if we do f of negative 2, we get negative 2. Which means there should be a value between 1 and negative 2. And in the right order, it would be like that. Okay? So between negative 2 and 1, 0 is an easy number to start with. So I started with 0. And I did x1. I got my answer set up over here with my calculator work going on over here. What we're doing. I plug in, do the 0, and x1 ends up being 1. I hit answer again. I'm sorry. Oh, I got this all written wrong. This is a little off. x2, it was a different sign. So x2 was 0. x3 was 1, x4 was 0, x5 was 1, x6 was 0. It keeps bouncing back and forth between 0 and 1. And if you look at it by a picture, you can see why. When x is 0, we follow the I don't want to do that. Let's do highlighter mode. Get a little small circle going on. X is 0, we go up, we follow it down. From there, we go up, we follow the tangent, and it gets us right back to 0. So it keeps us ricocheting back and forth between two positions. Okay? So it turns out x0 equaling 0 was not a good choice. And we can see over here, it's like above negative 2, or right below negative 2, or right above negative 2, but below negative 1. If I had started with negative 1, and I did negative 1.5, but negative 1 would have been a good starting point too. When you do this approach, you see that we approach the actual root at negative 1.769, and it turns out to work pretty well, okay? So sometimes we don't have a good answer, a good root, okay? And sometimes it wildly ricochets you back and forth all over the place. Sometimes it gets you going farther and farther and farther away. But you'll see those examples pop up when your answer is not getting closer and closer and closer. Notice how these are getting closer to each other. If your answer isn't getting closer and closer and closer to each other after several steps, you've probably got a bad starting number, or the method doesn't work at all. All right. We'll make this a short video. That's pretty good. Peace. Get that homework done, boys, girls, ladies, gentlemen, and people that are identify as non-binary. Have a good day.